Exercise 7.11, 11th question. Evaluate integral minus pi by 2 to pi by 2 sin square x dx. See here, this given definite integral is of the form integral minus a to a f of x dx. We have a property, right? That is, we have a property integral minus a to a f of x dx is equal to 2 into integral 0 to a f of x dx. When f of x is an even function, right? Otherwise, this integral is equal to 0. That is, if f of x is an odd function, then this integral is equal to 0. Okay, so for that, here we can apply this property. Before applying this property, we have to check whether this given integrand is an even function or odd function, right? So here, for that, how to check given function is an even function or an odd function? See here, we know that f of minus x is equal to f of x. If f of minus x is equal to f of x, then given function is an even function. Okay? Then f of x is an even function. Okay? Then if f of minus x is equal to minus f of x, then given function f of x is an odd function. Okay? So here let's check whether this function is an even function or an odd function. Okay, here f of x is equal to sine square x. Right? Now we have how to check given function is an even function or odd function? F of minus x. What is f of minus x? F of x is equal to sine square x. What is f of minus x? Replace x by minus x, right? Sine square minus x. See, sine square minus x means we know that sine square x is nothing but sine x into sine x. Sine square of minus x is sine of minus x into sine of minus x, right? That is sine of minus x into sine of minus x. Okay, what is sine of minus theta? Minus sine theta, right? Sine of minus theta minus sine theta. We have already studied it in trigonometric functions, right? Okay, so sine of minus x is minus sine x. That is minus sine x into minus sine x, right? Minus minus become plus, so it is sine square x. What is sine square x? That is nothing but f of x, right? See, we have got f of minus x is equal to f of x. That is, this given function, that is f of x is an even function. Okay, f of x is an even function, that is sine square x is an even function. Okay, so here sine square x is an even function. Okay, so here next we will apply this property. That is, if it is an even function, then this integral is equal to 2 into integral 0 to a f of x dx. That is integral minus pi by 2 to pi by 2 sine square x dx, that is equal to 2 into integral 0 to a, what is a? Pi by 2. Pi by 2, 0 to pi by 2 sine square x dx. Okay, now we have to find this integral, right? See, this integral is of the form integral 0 to a f of x. See, we can find this value, we can evaluate this integral by two methods. See, one is we can apply trigonometric identities. We can integrate. Sine square x is nothing but 1 minus cos 2x divided by 2. Or another method is you can apply another property. That is, see, this integral is of the form integral 0 to a f of x dx. Right? What is integral 0 to a f of x dx? Integral 0 to a f of a minus x dx, right? So let's apply this method. Means here we will find this integral, okay? So here we will take this integral as I, okay? Let I is equal to this integral. Integral 0 to pi by 2 sine square x dx. Okay, we have already done this problem. Okay, integral 0 to pi by 2 sine square x dx. Now apply the property. Integral 0 to pi by 2 sine square a minus x, that is pi by 2 minus x, okay, pi by 2 minus x dx. What is sine pi by 2 minus x? Cos pi by 2, that is cos x, right? So here sine square pi by 2 minus x is cos square x. So this integral is integral 0 to pi by 2 cos square x dx. Okay, it is I, it is also I, because Why it is I? This one we have got it from this integral, right? So here we have taken it is I and it is also I. So we will add these two integral, that is 2I. Okay. So 2I is equal to integral 0 to pi by 2 sin square x plus cos square x dx. That is equal to integral 0 to pi by 2 1 dx. Integral of 1 with respect to x is x 0 to pi by 2, that is pi by 2 minus 0. So here 2I is equal to pi by 2. Therefore, I is equal to pi by 4. Okay. So, what is I here? Not this one. Okay. I is this one. Right. We have taken this integral as I. So, we have to evaluate this integral. Right. So, this integral is nothing but, that is, this integral is equal to 2 into, it is I. What is I? I is equal to pi by 4. 2 into pi by 4, that is pi by 2. So, pi by 2 is the value of this integral. Evaluate integral 0 to pi x divided by 1 plus sin x dx. Very important. Here, see, given definite integral is of the form integral 0 to a f of x dx, right? So, we can apply property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Okay, so here, let's take it as I is equal to integral 0 to pi x divided by 1 plus sin x dx. Let's apply the property. So, it is equal to integral 0 to pi f of a minus x. In place of x, we should write a minus x. What is a here? Pi, right? So, pi minus x. So, here in place of x, we should write pi minus x. Pi minus x divided by 1 plus sin pi minus x. Okay? Dx. That is equal to integral 0 to pi. See, 1 pi minus x in denominator 1 plus, see what is sin pi minus x? Sin pi minus x, sin pi minus theta. Pi means that is 2 into pi by 2, right? So, we know that sin pi minus theta is sin theta itself, right? Sin pi by 2 minus theta, cos theta. But sin pi minus theta is sin theta itself, right? So, sin pi minus x is sin x, right? So, sin x dx. Okay. So, what is it? I, right? So, it's also I. We will add these two integrals. Okay. That is 2I. Okay. It is I and we have got it from this I, this integral, that is I. So, when we add these two integrals, it will become 2I, right? So, 2I is equal to integral 0 to pi, limits are same, right? So, we can add it directly, that is x plus pi minus x divided by, denominators are same, okay? 1 plus sin x dx. Then, that is equal to integral 0 to pi, here x minus x cancelled, pi divided by 1 plus sin x dx. Okay. Then, after that, here that is equal to, here we will multiply and divide by 1 minus sin x. So that our denominator will be 1 plus sin x into 1 minus sin x, that will be 1 minus sin square x. 1 minus sin square x is cos square x. Okay. So that let's multiply and divide by 1 minus sin x. Integral 0 to pi. Pi is constant, right? So let's take it up from the integral. Okay. So here 1 minus sin x. Multiply 1 minus sin x, divide by 1 minus sin x. Okay, dx. That is equal to integral 0 to pi, pi into integral 0 to pi. Here it will be, it is 1 minus sin x divided by 1 minus sin square x dx. That is equal to pi into integral 0 to pi. Here 1 minus sin x divided by cos square x dx. Now, let's split it. 1 by cos square x minus sin x by cos square x. Okay. So pi into integral 0 to pi 1 by cos square x is sec square x minus sin x by cos square x is sin x by cos x is tan x. So 1 by cos x is sec x. So sin x by cos square x is sec x into tan x, right? Dx. Okay. Now we can integrate it, right? Because we know that it is the derivative of tan x and it is the derivative of sec x, right? Therefore, integral of sec square x is tan x. Integral of sec x into tan x is sec x, right? After that, we will substitute upper limit and lower limit. That is equal to, here integral of sec square x is tan x 0 to pi. Pi is here, okay? Pi into, let's apply the limit together, okay? So pi into tan x minus sec x. Integral of sec x tan x is sec x. Limits 0 to pi. That is, first of all, first we have to apply substitute upper limit value, that is pi. Tan pi. What is tan pi? See, sin pi divided by cos pi. See, what is sin pi? 0, right? 0 divided by cos pi is minus 1. So it is tan pi is 0, okay? So it is pi into 0 minus sec pi. See, what is sec pi? 1 divided by cos pi. Cos pi is minus 1. So sec pi is also minus 1. So minus minus become plus 1. Okay. Next, minus of, here, next lower limit. Okay. Upper limit minus lower limit. Okay. So now substitute x is equal to 0. What is tan 0? Tan 0 is 0. Right? Because sin 0 divided by cos 0. Sin 0 is 0. Okay. Therefore, tan 0 is 0 and sec 0 is 1. Cos 0 is 1. Sec 0 is also 1. Okay. So that is minus 1. That is equal to pi into, here 0 plus 1 that is 2 pi. Right. So 2i is equal to 2 pi. So I is equal to pi. Okay. I is equal to pi. What is I? Okay, this integral. Okay. So given integral, definite integral, that is its value is equal to pi. Next question is, evaluate integral of minus pi by 2 to pi by 2 sin raised to 7x dx. See, this integral is of the form integral minus a to a f of x dx. So we can apply the property integral minus a to a f of x dx is equal to 2 into integral 0 to a f of x dx when f of x is even. Okay. And if it is f of x is odd, then this integral is equal to 0. Okay. If it is f of x is odd function, then this integral is equal to 0. Okay. So for that we have to check whether this sin raised to 7x is an even function or an odd function. We know that, see, sin raised to 7x, that is f of x is equal to sin raised to 7x, right? F of minus x is equal to sin raised to 7 of minus x. See here, that is sin of minus x into that is 7 times, right? So here multiply 7 times. So that is, we know that sin of minus x is equal to minus sin x. So minus sin x into 7 times, multiply 7 times, right? So here when we multiply minus into 7 times, that will be minus itself, right? If just you check if it is an odd number, then this function is an odd function. Okay, because we know that sin of minus x, sin of minus theta is equal to minus sin theta. You just remember, if it is an odd number, then this function is an odd function. If it is an even number, then this function is an even function. Okay, so here it is nothing but minus sin raised to 7x. Okay, that is minus f of x. So this given function is an odd function. So what is the value of the given integral? 0. Okay, if f of x is an odd function, then integral minus pi by 2 to pi by 2 sin raised to 7x dx is equal to 0. Okay, you can just write, since sin raised to 7x dx, sin raised to 7x dx, sin raised to 7x is an odd function, odd function, integral minus pi by 2 to pi by 2 sin raised to 7x dx, that is equal to 0 by the property of integral. Okay. Evaluate integral 0 to 2 pi cos raised to 5x dx. See here we have a property integral 0 to 2a f of x dx is equal to 2 into integral 0 to a f of x dx when if f of 2a minus x is equal to f of x. Otherwise it is equal to 0. If f of 2a minus x is equal to minus f of x, then it is this integral is equal to 0. Okay, so here we will find what is 2a here, 2 pi, right? So here f of x is equal to cos raised to 5x, right? So what is f of 2a minus x, that is 2 pi minus x, that is cos raised to 5, in place of x we should write 2 pi minus x, right? 2 pi minus x. So what is cos 2 pi minus x? What is cos 2 pi minus theta? Cos theta itself, right? So cos raised to 5 2 pi minus x is cos raised to 5x. That is nothing but f of x, right? So here f of 2a minus x is equal to f of x, right? Therefore we will apply this property, that is integral 0 to 2a f of x dx is equal to 2 into integral 0 to a f of x dx. Therefore this given integral 0 to 2 pi cos raised to 5x dx, that is equal to 2 into integral 0 to pi, okay, what is a pi, right? 2 into integral 0 to pi f of x cos raised to 5x dx. Okay, now how to integrate? See here, now this integral is of the form integral 0 to a f of x dx. Integral 0 to a f of x dx. We can apply another property, integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Okay. So for that, here we will take it as I. Okay. I is equal to, let I is equal to integral 0 to pi cos raised to 5x dx. Apply the property, integral 0 to pi f of a minus x, that is cos raised to 5 a minus, what is a? Pi minus x dx. Okay, what is pi minus theta? Pi minus means in second quadrant. It lies in second quadrant. We know that in second quadrant only sine and cosec are positive, right? Cos is negative. Therefore, cos pi minus theta is minus cos theta, right? Therefore, this integral is integral 0 to pi minus cos raised to 5x, right? Since it is an odd number, it will be minus, okay? It is minus. Otherwise, it will be plus, okay? If it is an even number, then it will be plus. See, pi minus, it is 0, pi by 2, pi, 3 pi by 2. Pi minus means in second quadrant, okay? In second quadrant, cos is negative. Therefore, cos pi minus theta is minus cos theta, okay? Therefore, minus cos theta into minus cos theta into, that is into 5 times, multiply 5 times. So, though that will be, so it will be minus, right? So, minus cos raised to 5x dx. Okay, then see what it is. It is I, right? It's also I. Let's add these two integral, that is 2i. Okay, add these two integral. Therefore, 2i is equal to integral 0 to pi, limits are same, right? That is cos raised to 5x. Here we will add these two, okay? That is 2i is equal to cos raised to 5x and it is minus cos raised to 5x dx. See, what is it? Integral 0. What is the integral of 0? 0, right? Yes, 0. Okay. So here, what is I? I is equal to 0, right? So I is equal to 0. Therefore, here, what is I? Our I is nothing but this one, right? So we have to find integral 0 to 2 pi cos raised to 5x, cos raised to 5x dx. So that is this integral. That is equal to, it is I, 2 into 0, that is equal to 0. Evaluate integral 0 to pi by 2 sin x minus cos x divided by 1 plus sin x into cos x dx. Okay. See here also given definite integral is of the form integral 0 to a f of x dx. That is integral 0 to a f of a minus x dx. Okay. So here let us take it is this integral given integral as I. Okay. Let I is equal to integral 0 to pi by 2 sin x minus cos x divided by 1 plus sin x into cos x dx. Okay. Now let's apply this property. So that is equal to integral 0 to a f of x dx is equal to integral 0 to a f of a minus x. So we should replace x by a minus x. What is a? Pi by 2. So pi by 2 minus x. Sin pi by 2 minus x minus cos pi by 2 minus x divided by 1 plus sin pi by 2 minus x cos pi by 2 minus x dx. That is equal to integral 0 to pi by 2 sin pi by 2 minus x is cos x. Cos x minus sin x divided by 1 plus sin cos x. Sin pi by 2 minus x is cos x. Cos pi by 2 minus x is sin x dx. Okay. It's also I, right? So we will add these two integral I plus I. Okay. That is 2i. So 2i is equal to integral 0 to pi by 2. Add these two sin x minus cos x. Okay. Denominators are same. So we can add directly. So sin x minus cos x plus cos x minus sin x plus cos x minus sin x. What is the denominator? 1 plus sin x into cos x dx. That is equal to, see here, what is the numerator? Sin x minus sin x cancelled. Minus cos x plus cos x cancelled. So it is 0. So that is integral of 0. That is 0, right? So here I is equal to 0. If I is equal to, that is this value of this given definite integral is equal to 0. Evaluate integral 0 to pi log of 1 plus cos x dx. So it's very important question and it's very lengthy also. Okay. So here see given definite integral is of the form integral 0 to a f of x dx. So first of all apply this property. Integral 0 to pi f of a minus x dx, right? That is log of 1 plus cos pi minus x dx. That is equal to integral 0 to pi log of 1. See cos pi minus x. Pi minus x in second quadrant. It lies in second quadrant. In second quadrant cos is negative. Therefore cos pi minus x is minus cos x, right? So 1 minus cos x dx. Okay. Now here next we will apply trigonometric identity. We have a trigonometric identity 1 minus cos 2x. 1 minus cos 2x is equal to sin square x. 2 sin square x. But here we have only 1 minus cos x. So 1 minus cos x is equal to 2 sin square x by 2. When it is 2x, here x. When it is x, it is x by 2. Okay. So 2, let's substitute integral 0 to pi log of 2 sin square x by 2 dx. Okay. Next we will apply logarithmic rules. See log of x into y. X into y. X is 2, y is sin square x by 2. Okay. So let's apply the property of logarithmic rules. That is log x into y is log x plus log y. Right. Log x into y is equal to log x plus log y. Okay. So this can be written as integral 0 to pi log 2 plus log sin square x by 2 dx. Okay. Then see here, let's split it. It's a constant. So this can be written as integral 0 to pi log 2 dx plus this one integral 0 to pi log sine square x by 2 dx. Okay, here again we can apply logarithmic rules. See, log of sine square x by 2, that is log of x raised to n, that is n log x. Okay, log x raised to n is equal to n log x. Here log sine square x by 2, that is equal to 2 log sine x by 2. Okay, so here what is the integral of this one? Log 2 is constant, and if we take log 2 outside, so integral 0 to pi 1 dx. Okay, 1 dx plus integral 0 to pi, we can write it as log 2 log sine x by 2. Okay, see, it's in the form of log x raised to n. Log x raised to n is equal to n log x. Therefore, it is 2 log sine x by 2. Okay, dx. Now, what is the value of this one? Log 2 into x limits 0 to pi. Okay, plus integral 2 into integral 0 to pi log sine x by 2 dx. Okay, that is equal to, now we will evaluate this one, log 2 into pi minus 0, so pi. Okay, so pi into log 2 plus 2 into integral 0 to pi log of sine x by 2 dx. Okay, here we will integrate this one. Okay, to integrate this one, see, first of all, here we will change the variables. Okay, here it is x by 2, right? So let's make it x, or only one variable, that is t. Okay, sine of t. See, that then only we can apply this property, that is, see, we cannot value sine of pi minus x divided by 2, right? If it is sine of pi minus x, we can say it is cos x, right? It is sine x. So here, let's put t is equal to x by 2, so that it will be sine t, right? Okay, so here put t is equal to x by 2. Okay, and remember, when variable changes, limits will be changed. Okay, lower limit and upper limits will be changed, because here the limits are, here x varies from 0 to pi. Okay, x values between 0 to pi. Okay, therefore when x changes, here limits will be changed. Okay, so put t is equal to x by 2, dt is equal to dx divided by 2, that is 2 dt is equal to dx. Then let's find the limits. When x is equal to 0, what is t? When x is equal to 0, substitute x is equal to 0. So 0 by 2, that is t is equal to 0. Okay. When x is equal to pi, t is equal to pi by 2. Okay. Now this integral will become, that is pi log 2 plus 2 into integral 0 to pi by 2 log of, here see, log sine t, log sine t dx is equal to 2 dt, right? So it will become 2 into 2, 4. Okay, dt. Okay. Now we have to integrate this integral 0 to pi by 2 log sine t dt. Okay, let's integrate it. Okay, see, here we have to find the integral of this one, right? So here we will find this integral separately. Okay, not in variable t, x itself. Okay, we will find what is the integral of 0 to pi by 2 log sine x dx. Okay, so here separately we will find integral 0 to pi by 2 log sine x dx. Very important, integral 0 to pi by 2 log sine x dx. If you know value of this integral, we can directly substitute here, right? Okay, so how to find integral 0 to pi by 2 log sine x dx? Okay, here we will apply the property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx, right? That is equal to integral 0 to pi by 2, okay, log of sine pi by 2 minus x dx. That is equal to integral 0 to pi by 2 log of sine pi by 2 minus x is cos x, right? So log cos x dx. Okay. So before that, here let us take this integral as I. Okay. Let I is equal to this integral. Okay. I is equal to integral 0 to pi by 2 log sin x dx. And what is it? It's also I. We will add these two integral. That is it will be 2y. Right. It's also I. It's also I. That is integral 0 to pi by 2 log sin x dx plus integral 0 to pi by 2 log cos x dx. Okay. That is 2i is equal to, okay, 2i is equal to integral 0 to pi by 2. Adding these two integral, okay, that is 2i. 2i is equal to log of, limits are same, therefore we can write directly, that is log sin x plus log cos x, okay, dx. That is equal to, that is 2i is equal to integral 0 to pi by 2, apply logarithmic rules, log x plus log y. Log x plus log y is log x into y. Okay. Log sin x into cos x dx. Okay. See here we cannot integrate it. So here we will change this integral into in this form. Okay. We will change this integration to this integration. Okay. So for that, here we have to apply trigonometric identity. See, we have a trigonometric identity 2 sin x cos x is equal to sin 2x. Right? So here we have only sin x cos x. So sin x cos x is equal to sin 2x by 2. Right? So let's substitute here. Integral 0 to pi by 2 log of sin 2x divided by 2 dx. Okay. See, again we have to apply logarithmic rule. It's in the form of log x by y. Log x by y. Log x minus log y. Okay. That is equal to integral 0 to pi by 2 log of sin 2x, okay, minus log 2 dx. Okay. So that is equal to integral 0 to pi by 2 log sin 2x dx minus integral 0 to pi by 2 log 2 dx. Okay. See, look at the first integral. See here we have got here log sin 2x. Integral 0 to pi by 2. Here it is, see, as I mentioned, see, we have to change this integral to in this integral, that is in this form, right? So here integral 0 to pi by 2 log sin x, but here it is log sin 2x, right? So for that we have to change it to in this form, right? So for that put t is equal to 2x, okay? Put t is equal to 2x. So here put t is equal to 2x, so dt is equal to 2 dx, okay? So dx will be dt by 2. So and when variable changes, limits will be changed. Okay. So what will be the limit? When x is equal to 0, t is equal to 2 into 0, 0. Okay. When x is equal to pi by 2, here x varies from 0 to pi by 2. Okay. So t is x is equal to pi by 2, t is equal to 2 into pi by 2, that is t is equal to pi. Right. So this integral will become integral 0 to pi log sin t, what is dx? dt divided by 2. So 1 by 2 into log sin t dt. See, here our integrand is same, right? Log sin x dx, here log sin t dt. Okay. But limits are different, right? Here 0 to pi by 2, but here 0 to pi. So for that, here we will apply another property of integral. See, don't forget this term, integral 0 to pi by 2 log 2 dx. Okay, we have got 2i is equal to 1 by 2 into 0 to pi, integral 0 to pi log sin t dt minus integral 0 to pi by 2 log 2 dx. Okay, we can integrate it directly, very easily. We will get the value of this one. Okay, but here, see, actually here we have to change this integral to this one, right? But here our limits are 0, here 0 to pi by 2, but here 0 to pi. So for that, here we will apply another property of integrals, that is integral 0 to 2a f of x dx, that is equal to 2 into integral 0 to a f of x dx when if f of 2a minus x is equal to f of x. Okay. See, otherwise it will be 0. If f of 2a minus x is equal to minus f of x, this integral is equal to 0. Okay. See, why we will apply this property? Here, see, we should get pi by 2, right? So, half of pi, that is pi by 2, right? So, if this satisfies, then we can write this integral is equal to integral 2 into integral 0 to pi by 2 log sin t dt, right? So, here, let's see. Let's apply this property. Okay, we can evaluate it very easily, right? So 1 by 2 into integral 0 to pi log sin t dt minus, here what is it? Log 2 into integral of 1, that is x. So when after substituting upper limit and lower limit, it will be pi by 2. Okay, log 2 into pi by 2. Okay, pi by 2 into log 2. Okay, then here we have to apply this property. Okay, that is 1 by 2 into integral of 0 to pi. Okay, before that we have to check, right, whether this function, that is f of 2a minus, if f of 2a minus x is equal to f of x, then only we can apply this property, right? So here let's check what is f of 2a minus x. What is 2a here? Pi. Okay, that is here f of x is equal to, f of x is equal to log sin t. Okay, f of t. Okay, f of t is equal to log sin t. So what is f of 2a minus t? That is, here 2a is pi, pi minus t, that is log of sin pi minus t. What is sin pi minus t? Sin t itself, right? So it is log sin t, that is nothing but f of t. Okay, so it's satisfied, right? So here, therefore, we can write this integral as 1 by 2 into 2 into integral 0 to pi by 2 log sin t dt minus, here pi by 2 log 2. Okay, see, what is it? We have taken integral 0 to pi by 2 log sin x dx is equal to, see, if you put you just put t is equal to x, you will get the same integral. Okay, if you put t is equal to x, so it will be log sin x dx and limits also same, right? So limits also 0 to pi by 2. Okay, so what is it? It is nothing but, see, we can write it as again 2 cancelled, integral 0 to pi by 2 log sin x dx minus pi by 2 log 2. So what is it? It's nothing but our I. Okay, it is I, that is equal to I minus pi by 2 log 2. Okay, so what is here? 2i is equal to this one. Okay, 2i is equal to this one. So take this I left side. Okay, 2i minus I. Okay, so here it will be 2i minus I is equal to, we have taken I left side, so 2i minus I, that is equal to minus pi by 2 log 2. Okay, that is I is equal to minus pi by 2 log 2. What is I? I is this integral. That means integral of 0 to pi by 2 log sin x dx is equal to minus pi by 2 log 2. Okay, that is, we can substitute here. Okay, we have to find this integral, right? This one is equal to pi log 2 plus 4 into integral 0 to pi by 2 log sin t dt. Actually here we have found this integral. Okay, we have found the value of this integral, right? That is nothing but minus pi by 2 to log 2. Substitute here. That is pi log 2 plus 4 into minus pi by 2 log 2. Okay, so here both terms log 2 is common. So let's take it out. Log 2 into here pi minus here 4 by 2, it is 2 minus 2 pi. That is equal to log 2 into minus pi, okay, minus pi log 2. Evaluate integral of 0 to a root x divided by root x plus root a minus x dx. Here also we will apply same property, that is integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So this integral is equal to integral 0 to a minus x. Here a itself, so root, in place of x we should write a minus x, okay, a minus x divided by root of a minus x plus root of a minus, in place of x, a minus x, okay, dx. That is equal to integral 0 to a root of a minus x divided by root of a minus x plus root x, okay, minus become plus. So here, see, first of all here we have to take, we should take this one as I, okay, take it is I, okay, I is equal to integral 0 to a root x divided by root x plus root a minus x. So we have got this integral is equal to this one. We will add these two integral, that is 2i, okay. So 2i is equal to integral 0 to a root x, numerator, denominators are same, so we can add it directly, right. So root x plus root a minus x, what is the denominator? Root x plus root a minus x dx. That is equal to integral 0 to a 1, right, 1 dx. That is equal to integral, let's integrate it, integral of 1 with respect to x is x, limits 0 to a, that is equal to a minus 0, that is equal to a. So 2i is equal to a, okay, not this integral is equal to a, 2i is equal to a, I is equal to a divided by 2. Integral 0 to 4 modulus x minus 1 dx. So here we will apply the properties. Integral 0 to a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx, right. So in modulus function, so first of all for that we will define this modulus function, modulus x minus 1, that is equal to x minus 1 when if x minus 1 greater than or equal to 1, sorry, greater than or equal to 0, right. That means x is greater than or equal to 1. And modulus x minus 1 is equal to minus of x minus 1 if x minus 1 less than 0, that is x less than 1, okay. So here what is our c? C is 1, okay. Then we can write this integral 0 to, we know that this 1 should be, and you just confirm that this 1 should be in between 0 and 4. Okay, 1 is between 0 and 4. Okay. So here 0 to 1, okay, modulus x minus 1 dx plus integral 1 to 4 modulus x minus 1 dx. Okay, now let's write the function modulus. Modulus we cannot integrate, right? So what is modulus x minus 1? Modulus x minus 1 is equal to x minus 1 when x greater than 1. Where x greater than 1? Here, right? See, here 0 to 1. 0 to 1 means 0 less than x less than 1. Here x is less than 1. When x greater than 1, it is positive. Okay, when x less than 1, here it is minus x minus 1. Okay, so function is integral 0 to 1 modulus x minus 1 is equal to minus of x minus 1. Minus of x minus 1 dx plus here modulus x minus 1 is equal to x minus 1 when x greater than 1. Means here integral 1 to 4 means x varies from 1 to 4. 1 less than x less than 4. See here x greater than 1. When x greater than 1, modulus x minus 1 is equal to x minus 1. Integral 1 to 4 modulus, sorry, x minus 1 dx. Okay, now let's integrate it. Take minus outside. Okay, minus. Here x minus 1 whole square, integral of x dx is x square by 2. x minus 1 is x minus 1 whole square by 2, limits 0 to 1, plus here also x minus 1 whole square by 2, 1 to 4. Okay, then that is equal to minus of. So first of all, let's substitute upper limit value. Put x is equal to 1. See, first term will be 0, right? 1 minus 1, that will be 0. Okay. Then next minus, substitute lower limit. Put x is equal to 0. So 0 minus 1 minus 1. Minus 1 square is 1. So 1 by 2. 1 by 2. Plus here substitute x is equal to 4. 4 minus 1 is 3. 3 square is 9. So 9 by 2 minus, next lower limit, 1 minus 1 0. So it will be 0. Okay. That is equal to minus minus become plus. See, one more thing, you should be careful about minus plus. Okay. So here minus into minus. Minus is here. Minus into minus plus 1 by 2 plus 9 by 2, that is 10 by 2, that is equal to 5. Show that integral 0 to a f of x into g of x dx is equal to 2 into integral 0 to a f of x dx if f and g are defined as f of x is equal to f of a minus x and g of x plus g of a minus x is equal to 4. Okay. So our integral is this one. We have to prove this. Okay. Integral 0 to a f of x into g of x dx, that is equal to, let's apply the property integral 0 to a f of x dx. Okay. That is equal to integral 0 to a f of a minus x dx. Integral 0 to a f of a minus x into g of a minus x dx. Okay. Then let's substitute here. What is f of a minus x? See, it is given that f and g are defined as f of x is equal to f of a minus x. F of a minus x is equal to f of x. Integral 0 to a f of a minus x is equal to f of x. G of a minus x is equal to, see here, g of x plus g of a minus x is equal to 4. So g of a minus x is equal to, take g of x right side, so it will be 4 minus g of x. 4 minus g of x dx. Right? That is equal to integral 0 to a, expand f of x into 4, that is 4 f of x dx minus integral 0 to a f of x into g of x. F of x into g of x dx. Okay. See, here we have got the same integral. So for that, here let's take I is equal to this integral. Okay. That is given integral. Integral 0 to a f of x g of x dx. And here it is nothing but I, right? So now we can write it as I. Integral 0 to a 4 f of x dx minus I. Okay. So it is I is equal to this one, right? So let's take this I here. So it will be 2I. Okay. It is minus I. When we take this left side, it will be plus I, right? So I plus I, 2I. That is equal to 4 into integral 0 to a f of x dx. So what is I? That implies I is equal to, take 2 here. So 4 by 2, that is 2 integral 0 to a f of x dx. See, this is what we have to prove. Okay. I is equal to 2 into integral 0 to a f of x dx. The value of integral minus pi by 2 to pi by 2 x cube plus x cos x plus tan raised to 5x plus 1 dx is dash. See here, this integral is of the way integral minus a to a f of x dx, right? We have a property integral minus a to a f of x dx, that is equal to 2 into integral 0 to a f of x dx when f of x is even, right? Otherwise it is equal to 0. If f of x is odd, it is equal to 0. Okay. So for that, here let's take given function, that is given integrand is an even function or odd function. Okay. So for that, it is f of x, right? So what is f of, how to check whether the function is even or odd? F of minus x is equal to minus f of x, then it is odd. If f of minus x is equal to f of x, then f of x is even function. Okay, so let's find f of minus x. F of minus x is equal to, here it is f of x, f of minus x is equal to, substitute x is equal to minus x. Okay, so minus x whole cube plus minus x into cos of minus x plus tan raised to 5 of minus x plus 1. That is equal to, here minus x whole cube is minus of x cube, right? Plus here cos of minus x is cos x itself, but here minus x is there, so we can take minus outside, we can write x into cos x, because cos of minus theta minus cos theta, right? So cos of minus x cos x plus here next term tan raised to 5 minus x. We know that tan of minus theta minus tan theta. So since it is an odd number, it is minus itself, right? So tan raised to 5 of minus x is nothing but minus tan raised to 5x, right? Okay, that is equal to, sorry, minus tan raised to 5x. It is plus 1. See here, we can take minus outside, so it will be, here let's take only these three terms. Okay, no need of this one, we can integrate it separately. Okay, so here let's take f of x is equal to only this one. Okay, so here for that, that is f of x is equal to only these three terms. So that is equal to, here we can take minus outside, so it will be minus x cube plus x cos x plus tan raised to 5x. That is equal to f of minus f of x, right? So here this, when we take these three terms, it's an odd function, right? So here no need to integrate here. That is equal to integral, this integral can be written as minus pi by 2 to pi by 2 x cube plus x cos x plus tan raised to 5x plus, let's integrate it separately. Okay, integral minus pi by 2 to pi by 2 1 dx. Okay, so here we have taken, it is x, sorry, f of x. Okay, this f of x is an odd function, because we have proved f of minus x is equal to minus f of x. That means this function is an odd function. Therefore, its value, integral, that is value of this integral is 0. Okay, since it is an odd function, this value is 0. Its value is 0. Okay, that is integral minus pi by 2 to pi by 2 x cube plus x cos x plus tan raised to 5x dx is equal to 0. Plus, now we will integrate it. Okay, that is integral of 1 is x minus pi by 2 to pi by 2. That is equal to, here pi by 2 minus pi by 2 plus pi by 2. Okay, x, that is pi by 2 minus lower limit, so minus of minus plus. Okay, so 2 pi by 2, that is pi. So pi is the answer. The value of integral 0 to pi by 2 log of 4 plus 3 sin x divided by 4 plus 3 cos x dx is dash. Okay, so here also we will apply the property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So integral 0 to pi by 2 log of 4 plus 3 sin x divided by 4 plus 3 cos x dx, that is equal to integral 0 to pi by 2, applying the property, log of 4 plus 3 sin a minus x, pi by 2 minus x, right? Pi by 2 minus x divided by 4 plus 3 cos pi by 2 minus x dx. Okay, that is equal to integral 0 to pi by 2 log of 4 plus 3 sin pi by 2 minus x is cos x divided by 4 plus 3 cos pi by 2 minus x is sin x dx. Okay, see here, Let's take it as I. Okay. Let I is equal to integral 0 to pi by 2 log of 4 plus 3 sin x divided by 4 plus 3 cos x. We have got it, this one. Okay. That means here it is the denominator, here it is in numerator. Okay. So here what we have, we know that a logarithmic rule, log of x by y, that is equal to minus log of y by x, right? Why? Because log x by y is log x minus log y, right? And log y by x is log y minus log x. That is minus of log y minus log x is nothing but log x minus log y. Right? When we multiply this one, minus log y plus log x, right? So here remember, log of x by y is equal to minus log of y by x. Okay, therefore this one can be written as, see here, it is denominator, numerator, and numerator is in denominator, right? Okay, so this one can be written as integral 0 to pi by 2 minus integral 0 to pi by 2 4 plus 3, interchange the, that is, we will take the reciprocal, okay, minus of its reciprocal, that is log of reciprocal, okay, 4 plus 3 sin x divided by 4 plus 3 cos x, okay. Here it is x by y, here it is y by x, so that is equal to minus of log x by y, okay, that dx. So what is it? We have taken I is equal to this one, right? So that is, therefore it is minus I. Okay. So here we have got I is equal to minus I. Take this I left side. So I plus I, that is equal to, here left side, it will, right side, it will be 0, right? We have taken I left side. So that is equal to 0. That implies 2I is equal to 0. That implies I is equal to 0. That means this value of this integral is equal to 0.